Precision Polymer Engineering manufactures high-performance elastomer O-rings and seals for semiconductor applications around the world. Having been an innovator of elastomer sealing solutions in this industry for many years, PPE's material brands of Purelast, Kimura, and NanoFluor are trusted by leading semiconductor OEMs and fabs. This video shows the complete manufacturing process of how clean O-rings are made for semiconductor applications at PPE. PPE's UK manufacturing facility and head office is based in Blackburn in the northwest of England. The US manufacturing plant is located in Brenham, Texas. Both facilities contain ISO Class 6 and Class 7 clean rooms for the manufacture of critical components in controlled environments, which minimize pollutants such as dust, airborne microbes, particles, and chemical vapors. The first step in manufacturing an O-ring is selecting the correct mold tool. PPE holds thousands of tools for molding standard size O-rings. The smaller sizes are stored in a computerized system, and larger tools are stored in racking, all ready to use at a moment's notice. Each O-ring mold is comprised of two halves, a top and a bottom. If the O-ring required is a custom size, new mold tools can be manufactured in-house. This greatly reduces the time it takes to get the O-rings into production. The O-ring mold is cut from steel blanks using a high-precision lathe. Before going into the clean room manufacturing environment, the tools are polished using a plastic bead blaster, then cleaned with IPA wipes to ensure the highest level of cleanliness. The range of elastomer materials PPE offers is comprehensive, and correct material selection is key to seal performance. Elastomers derive their performance characteristics from the ingredients and additives that are in them. In the milling room, an operator compounds the elastomer material by mixing ingredients into the polymer to a proprietary formulation using a milling machine. The material is repeatedly passed between two metal rollers to disperse the ingredients evenly. Each material grade is unique based on the combination and amount of each ingredient used. Once the material is compounded, a sample piece is checked for adherence to PPE specification by conducting a rheometer test. This equipment measures the viscoelastic properties of the compound before, during, and after curing. The elastomer material arrives at the next stage as a sheet, which is cut into strips and inserted into an extruder. Once inside, the material is heated up to decrease its viscosity and forced through a die, which produces lengths of cord. The size of the die aperture is carefully selected based on the finished diameter of the O-rings required. During the molding stage, the cord is cut to size and placed into one half of the heated mold tools, which are fixed to the two platens of the press. When the two halves of the tool close, the elastomer material is molded into an O-ring shape. It is left in the press for a short length of time to start the curing process. When the press opens, the O-ring is carefully removed from the mold. This technique of manufacturing O-rings is known as compression molding. Larger O-rings of up to 2.5 meters, 8 feet in diameter, and custom shapes are precision molded on one of Europe's largest molding presses at PPE's Blackburn facility. Once molded, the O-rings often have excess material around the sides, where the two halves of the mold meet. This is known as flash. In the next stage of production called finishing, this flash can be removed in a number of ways to produce a perfectly round O-ring. Drumming. The O-rings are placed in a drum of rotating stones which rub the excess flash off. Blading. The excess material is carefully cut off using a sharp blade. Cryo. Small O-rings that are too delicate for any of the other finishing methods are placed in a metal drum. This rotates within a cryogenic environment. Liquid nitrogen cools the elastomer O-rings down until the flash is brittle and can be removed by shot blasting with grit. The deflashed O-rings are placed into ovens to complete the curing process. The length of time they are in the oven depends on the type of elastomer, but typically ranges from 2 hours to 18 hours. Once cooled, the O-rings are now ready for quality inspection. Trained operators use 2 times magnification, as stated in ISO 3601, or customer-agreed parameters, to visually inspect the O-rings for visual defects. The O-rings are measured using optical, non-contact measuring equipment, which accurately checks the dimensions of the finished part. Before the parts can be packaged, they are thoroughly cleaned in a number of ultrasonic clean tanks to remove any residual particles from the manufacturing process. The parts are placed into a basket and submerged into the first tank, which contains a strong cleaning solution. After 5 minutes, the parts are removed and rinsed with deionized water. They are then rinsed in 2 more tanks and finally placed in the dryer. The O-rings are now ready to be packaged as per the customer's requirements. Semiconductor parts are heat sealed into an inner bag, then bagged in a second outer bag for contamination control. Once bagged and labeled, the O-rings exit the clean room through a chute into a container ready for collection by the dispatch team. They are then shipped around the world. So now you know how our O-rings are made at PPE and why our O-rings are trusted to provide the highest quality and optimum performance for critical semiconductor applications. To find out more, visit our website at www.prepol.com.